Hello, I'm Jinung Moon. Today's presenter, I will review a paper named A Machine Learning Model on Simple Features for CO2 Reduction Electrocatalyst. CO2RR, which means CO2 reduction reaction, is an important process of sustainable production of fuels and value-added chemicals. High-throughput computation for every candidate requires huge cost and time-consuming. So, by introducing machine learning, we can quickly investigate 10,060 candidates and propose potential electrocatalysts. The catalyst model in this research is single-atom catalyst with dispersed metal non-metal cut-off graphene structure. SAC consists of transition metal, non-metal, carbon atoms as blue, green, gray balls. SAC is a catalyst showing high activity in CO2RR. Since delta GCO is an ideal value to describe catalytic performance for CO2RR, ML is constructed using this as a target feature. As an input feature, we select features which are easily accessible and related to the electronic structure. The ML model structure in this research is to predict the target feature, delta GCO, using multiple input features, including the above 12 features. If so, how can we get the database used for training? First of all, simple features can be obtained directly from the periodic table. Second, the most important input features are the electronic property features because the catalytic performance is generally dependent on each electronic structure. This database can be obtained from NIST. Finally, the target feature, delta GCO, this can be obtained through two equations, which include the DFT value and data from NIST. Therefore, the final goal is to perform the DFT calculation only for the catalyst to be trained and to make the DFT calculation unnecessary for the remaining candidates by using ML. In this study, 6 ML algorithms were implemented. As a result, the XGBL algorithm showed the best performance. XGBL algorithm has various advantages as shown in the figure above and is a popular and efficient open source implementation boosted trace algorithm. The gradient boost method is supervised learning algorithm that predicts the target variable. For reducing the number of features, two methods to help with this are the Pearson correlation coefficient matrix heat map and feature importance. The Pearson coefficient is a numerical value of the dependence between two specific features. Feature importance measures the contribution used to predict a target feature. By using these two methods, the prediction accuracy can be improved and the cost can be reduced. By using ML after feature selection, we investigate the performance of 10,060 catalyst candidates. Through previous studies, it can be seen that the delta GCO value of minus 0.3 to minus 0.1 electron volt is the most appropriate. It can be predicted that the catalyst corresponding to the part shaded in the blue in the figure above will have good performance for CO2RR. However, we should consider not only CO2RR but also HER. Similar to CO2RR, the target feature of HER is delta GH. Therefore, similar to the previous method, we create the heat map of delta GH. Through previous studies, it can be seen that the delta GH value of minus 0.1 to 0.1 electron volt is the most appropriate. Therefore, it can be predicted that the catalyst corresponding to the part shaded in red in the figure above will have good performance for HER. We use the overlapping method, which overlaps the previous two heat maps to consider both reactions. The purple color means that it has good performance for both CO2RR and HER. Therefore, these catalysts have low selectivity for CO2RR. Therefore, blue ones are the best catalysts for CO2RR. This process is final, and 94 catalysts out of 10,060 candidates can be proposed. These three catalysts are randomly selected for verification. After AIMD simulation, the structures are intact, which means the catalysts are stable. And when you compare the predicted and DFT-based delta GCO value, there was no significant difference. In other words, it can be seen that the prediction is very accurate. Finally, conclusion. In this study, the ML model used various features to predict delta GCO. By using correlation heat map and feature importance, we succeeded to make accurate prediction model. Through the above the ML model, we can earn the following benefits. ML model proposes 94 potential SACs for CO2RR among 10,060 candidates within less than a minute. So it reduces lots of time for calculating catalytic performance. ML model predict expensive value by using only cheap features without depth calculation. Cheap features mean easily accessible features, don't require high throughput computation. This is the uniqueness of the ML model that is different from the existing DFT-based calculation method. Finally, ML model is very effective screening method and excellent tool for preliminary investigations. These are the scientific questions to be answered in this research. Thank you for listening to this presentation.